Hi, thanks for joining this session. My name is Israel. I am from the south of Spain, from a city called Granada, that I really encourage you to visit. So, the thing is that I work as a software engineer at Red Hat in the District Recent group. Uh, Currently, I am working mainly contributing to the Tempo, Jaeger, and OpenTelemetry projects, especially to the Kubernetes operators. We'll see during this session what are those projects and well how can help you right to use in your day to day, right. Well, the things that also I am Google developer expert in Google Cloud, AWS community builder in the cloud operations category, and Google developer group organizer here in Granada. Well, I have been also helping organizing events in other places here in Spain. So the idea of the talk that you are gonna see today, it's a talk about um, how what is observability, right? That is something that has become very trendy in the last years. Is something that it's very interesting because it can help you a lot, uh, independently or where of what is your area of expertise. You can be maybe a site reliability engineer, right? Where these tools will help you a lot to see what's happening in your system and how you can maintain the system up and running. Or maybe if you are, for instance, a developer, it can help you to detect where the different bugs are or how the application can be improved in order to make it resilient. Well, ensure that everything continues working as expected. So, well, the thing is that nowadays the applications are like focused, right? The things are focused on make their applications ready to scale. If you are, it doesn't matter if you are working on a small company or in a big one, you have to be ready to scale, right? Even if you are, you maybe right now your application is not didn't find the product market fit and things like that, right? Uh, we are like pretty obsessed with this scaling thing, um, even when it's not needed, right? So it's just one thing that we desire from our work. So well, the thing is that currently we have this, right, and it's like not like in the old days where everybody was running the thing in their machines, right? So now we have clusters that are running the different software, and we have to take care of it to ensure that everything continues working. And well, our system became like pretty complex, right? We have now like containers that are running the containers of orchestrators like OpenShift or Kubernetes that can have one application instead of a monolith can be splitting across multiple microservices running different instances. Even at some point you can have two or three versions of the same application running at the same time in your cloud, right? While you are doing canary release or whatever. Um, and also, well, the number of instances of your services, right, are gonna be probably pretty high. Also, it can happen that you have multi-cloud, right? You are running, I don't know, maybe into providers like Azure and Google Cloud or AWS, or maybe you have in different regions, or you have a hybrid cloud where you have things on premise and others that are directly in one of those providers. But also we depend on third-party tools, not like just libraries, but also things like services that are running and are performing out of our control. Let's imagine, for instance, Google Maps or one of those APIs related to AI that have became pretty popular, right? So the thing is that it can happen that at some point we detect that we are experiencing one outage, and we have to notice where the problem, what is the source of the problem for that issue that we are experiencing, right? So it can happen that also the third party is what is failing. So we need it to detect, act depending on the third party or whatever, right? To continue providing service to our customers. So we're in the old days, right? We have our application, well, maybe while we were running it, at some point we can have some kind of failure, and we want to debug it, right? For sure we want to debug it and find what's happening. Maybe we introduce the same input values to reproduce the issue and check in our code, maybe with a debugger or something, what's happening. But while we are doing that, we are also receiving other errors, right? I know, talking about debugging on production stuff, that is something that also happens, right? But it's something more about doing that big differentiation between the old days where everything was run in our machines against now where everything is on the internet. Can you imagine trying to find one bug or something on this way, just checking the stack trace, right? When you have thousands of queries in different environments with different versions and also hundreds of instances of your applications, it's pretty difficult, right? So the thing is that to help, to try to help to solve this kind of problems is where observability appears, right? Observability, if you check what Wikipedia says, is some definition that I really like, because it's like a feature that your system has, a capacity where you can infer what's happening internally in the system, just getting the outputs from it, right? Some kind of outputs, of signals, of what's happening inside that system. So if you check about information related to observability, you will find that everybody is pointing to these three pillars of observability: metrics, logs, and traces. We will see later what is each one, but the thing is that from that data that you have, that is just data, right? You send that to a central place, to a Sauron eye, where you can do correlationship between the different signals and data that you have, and you convert it into information. With that information, you can take decisions and go and check what's happening, right, in your system. Even you can avoid issues before they happen. You can be thinking, well, this sounds like the old monitoring, right? So the thing is that yes, partially yes, because monitoring is part of observability. So you can with observability tools, you can have those dashboards where you can see different graphs about how your system is performing, what error rate you have, and things like that. And you can create alerts when something is not going well. when, for instance, you are seeing that your costs are increasing because, well, you are spending too many resources or something, right? But also you have things like profiling, doing debugging, doing tracing, doing dependency analysis. So it's like monitoring is part of that, but it's not the same, right? It's a something that completes the observability thing. Everything from this is based on disaster cannot be avoided, and it's because, well, we can be pretty good developing, we can have amazing tests, we can have the full coverage in our system. We can be doing TDD where we are saying our business, we are defining our business logic and everything, right, before implementing the thing itself. But, well, sometimes we are not gonna be taking all the corner cases into account. Maybe there is something that we are not testing properly. It can happen that there are outages, right? At some point, an environmental disaster, for instance, can happen near to a data center, and that data center can have a flood or whatever, right? So that kind of situations can happen too, or a third party is not working anymore, right? Your system is relying or on a third party. Imagine that, well, you have your system working, that third party breaks, and now your system is not working anymore, right? Also, the human error, that is something that also happens, right? Even when we have everything automated with CI/CD systems, it can happen that somebody modified something manually, or well, maybe during a code review, we accepted something where we didn't notice about one error. But also when we are developing, we also think that things like the resources are infinite, like memory, or that the networks don't have any kind of latency issues or reliability and things like that, right? Or maybe imagine that your system is deployed in one cloud in New York, and you are trying to access from the east of Europe, right? The requests are gonna need to go through different networks that will have different quality of services and things like that, right? And that will affect your application. I mean, the queries, right? So the idea is, with observability, we are gonna be able, or we are gonna try to detect these kind of things to fix them as soon as possible. So with this, we want to see what problem happened, when it happened, and why it happened, right? So we are gonna be like more efficient, finding the problems and going into them. There are several tools related to observability, and each day, if you go to the internet, you will be able to find more and more. We have tools like, for instance, for tracing, like Jaeger, that was originally developed by Uber, if I am not wrong. Tempo, that is from Grafana. For log management, we have things like Loki, that is also from Grafana, but we have Kibana, FluentD, Elastic, and other tools, right? For metrics and alerts, we have things like Prometheus and Thanos. And for management dashboards, if you're using, for instance, Service Mesh, you will have Kiali, but also you can have Grafana or OpenShift, right? As I said, these are not all the tools that are available for observability, just some of them, right? Well, now we are gonna do a small explanation about each one of the different signals that we have. So the first one, let's say, is the most ancient, right? It's logging. So when you have, let's imagine this scenario, right? when you have one application, in this case, that is a PHP application running in an Apache HTTP server, and that application is doing some interaction with a Redis database. So you have your application that should be generating logs. The Apache server is generating logs. The Redis database is also generating logs, and even the operating system, the container where you are running all that stuff, are generating logs. So the idea is that with something like, for instance, Bits or other software, right, you can get all the logs from the different applications, parse those logs, and get some insights about what is happening in your system. For instance, your application is trying to write something to another web service or to the database, right? And it's having problems with the network, it's having timeouts and things like that. You are gonna be able to see those messages in the logs, so you can act and maybe change the configuration or add a new check to your code, or maybe deploy more instances of the database or whatever, right? And later with one dashboard or something, you can see exactly what's happening, right? You are just storing the things, for instance, in this case in Elasticsearch, but later with other things you can see exactly the information. Metrics is another of the signals that actually have been there between us from the old days, where we were monitoring things with Nagios or Zabbix, right? Where we can see those nice graphs, seeing exactly how our system was behaving, right? So the thing is that now, in this case, I am going to talk about Prometheus, but there are other systems that are also amazing. Well, the idea is that you have different kind of metrics. You can have counters, you can have histograms, you can have gauges, where you can say things like, hey, for instance, right? I did one request to this microservice. Well, it was successful, or I have this problem, right? This error. So you can zoom 1 to different counters, or my application is using this percentage or this amount of memory or CPU, or I am doing this number of requests per second to one database. So in the case of the logging, we saw that here the information flow was like from the application right to the storage. Here is a little bit different for Prometheus, but just because how Prometheus work, right? So I think that for Prometheus, we publish one HTTP endpoint where we are publishing our information, and Prometheus will go to that endpoint and will get the metrics from there and will scrape them. So it will go, for instance, to the Kubernetes API, right? And we will get some information about all the places with target with metrics, right? And from it will be able to pull information from the metrics that your application are exposing, and also things like your database, the database that you are using are also exposing data, right? Without, you don't need to do anything, right? Because they were, maybe you have to enable the publishing of the metrics, but it's like you don't have to instrument the application, right? You have just to care about your application, not the also the third parties that you are deploying in your cluster. And also you can get information from the nodes, from the Kubernetes nodes, in the case that you are deploying in Kubernetes, right? So from that, you can get exactly how your application is behaving from the resource consumption point of view, for instance. With that information, later we can create some rules, right? So let's imagine we can create one rule that says, hey, Prometheus, alert me when, I don't know, the 90% that my applications are using the 90% of the memory that currently I have, right? So when you reach that number, you can you push one metric alert to the alert manager, right? And it will deliver notifications to your email, Slack, or whatever integration that you have with it, right? And also, you can have visualization tools to pull that information from Prometheus and see in a dashboard all that information, right? So, for instance, you will be able to see in a graph if you have a memory leak and you are not freeing your memory or something, right? So you can detect things there before it's a cost increasement or something, or if you can see that you deployed a new application, the number of errors raise pretty high, right? Pretty fast. You can do some changes to what you did, right, and redeploy, or maybe you can have some kind of automation to roll back what you did. Tracing is like the new guy, right? It's like a little bit more strange. Somebody told me something that was pretty, at least it's pretty interesting because it's true. People usually focus on having metrics and also logs, right? Because they are more or less easy to implement. They are not easy to be done properly, right? But they are easy to implement. Tracing is like a little bit more strange, right? So the thing is that with tracing, what we try is that when we have a request, we try to have a representation of the story of that request across our system. So in this case, we have some services, right? And we have a request here. And propagating the context, we can see the story of our request. We can have a Gantt chart where we can represent how much time that request took in our system, the dependencies that the microservices A have on B and E, right? And even how B is gonna be depending on C and D for this request. Sometimes something that happens when you have big systems is that if you are, for instance, as a reliability engineer, right, with, I don't know, 20 microservices, maybe you don't know exactly the dependencies the microservices have between them. But with this, it's like you can see on real time how the system is behaving. So if at some point there is an outage, let's imagine that we start seeing that A is going pretty slow or it's not working. Maybe the problem is not exactly in A, but it's in D, right? Because we can see that at some point we have a crash or whatever. So here, things that we can see, each one of these units is called a span, right? So A is an span, and A is like the full request, right? So it started here and finishes here, and it contains, we do some computing, right? We do something, and then we call V. And when we call V, we have some computing and we call C, right? So we can see the span start here, finishing here. After C, we call D, right? So it's like this. When we finish D, A call E. So with this, we can detect things like bottlenecks in our system. If at some point we start seeing that A goes pretty slow, we can see what is the service that is taking the most of the time here, and things like that. This is one screenshot from the Jaeger website where we can see that we have one service called frontend, right? And when we call this endpoint, right? But this endpoint will call this and this, right? And we can call this part from the driver of Redis, right? And how the code was done, everything, right? So we can see that this looks like a loop, and we have some problems here, right? So we can go click and see exactly what parameters were propagated and everything to see what is causing that issue. Okay. But well, this is pretty nice and everything, right? But when you want to do an instrumentation of one application, there are different ways, right? But let's imagine that all the instrumentation that you can do is manual. So it's like, okay, if I want to do metrics, I have to use this SDK. If I want to use logs, I have to use this other SDK. Also, if I want to use traces, I have a different library. And also, if I go to a different language, because I am using maybe in one application, I'm using Golang, and in the other one, I'm using Python. The SDKs can look different. And also, if you do some logging with one vendor, maybe at some point you want to change because of the cost or whatever. So it can be an issue, right? It can be like difficult to move to a new vendor or something. So the thing is that this is what OpenTelemetry tries to solve. OpenTelemetry is an open source project that came from Open Tracing and also Open Census, that are two products related to telemetry. The thing is that with this, you have like a vendor neutral SDK where you can create traces, metrics, and other things, right, and export them to different vendors. So for instance, if you are using Jaeger and want to change to, I don't know, Tempo, for instance, right? The only thing that you have to do is like from this OpenTelemetry thing, saying, hey, I want to export the traces now in this different format. The things that Tempo and Open and Jaeger can ingest some formats, I would say even all of them, I'm not sure, are compatible, right? But the thing is that if you are using another vendor, for instance, right, that only accepts OpenTelemetry or only Jaeger or only Zipkin traces, you can export that thing, right? Also, we have the hotel collector, that is something that you can deploy in your system, and you can report traces, metrics, logs to that collector, right? You have different receivers, you have components that are called receivers, and well, you can report the traces here, or the information, your telemetry data here, in OTLP format or Jaeger or other thing, and you can add, you can do some processing or things like also authenticating, ensuring that you are using authentication, right, in your thing to gather telemetry data. You can do batching, filtering the data because maybe you don't want to have everything stored, and later you can export with one exporter. You can export that telemetry data to another system. That can be something accepting the OpenTelemetry protocol, or maybe some Jaeger or Prometheus, or if you are using Google Cloud, maybe Stackdriver or something, right? So, well, now it's not called Stackdriver, it's called operations, if I'm not wrong. But well, the thing is that now this thing is vendor agnostic, right? So if you have in your system something instrumented with Prometheus, you can still send the data to something that just supports OTLP, right? Because you have this thing that translates and add some more information to your telemetry, and you don't have to change the full system, what is pretty nice, right? There are some companies, these are not the only ones that are contributing, right? Well, are some of the ones that I know, like Timescale, Red Hat, Google, Amazon, Grafana, Splunk, Datadog, like Step, right? You can go to the GitHub organization and contribute, because you have the SDKs for the different languages, and also the OpenTelemetry collector, the OpenTelemetry collector operator, and other things. So it's a pretty nice community that is really live. I encourage you to go there and work, because there are things that are pretty interesting there. So the things that Yuri, that is the creator of Jaeger, wrote this article that I think is like pretty interesting, because I show you that there are 3 pillars of observability, but those are the basic ones, right? They are like the old ones are the ones that the people are using right now, right? But Yuri says that actually there are 6 pillars, and I think that is pretty interesting, right? It's something that he published on September, and we're gonna talk about that, right? It's like the temple, so we can see it as something like this, right? We have the traces. We have been talking about them. We have the events. Events are different kind of events, right? It's not like events from the point of view of, for instance, one architecture, event driving or something like that, right? Events can be things like a new deployment, things that you have to take into account that also affect your system. For instance, a deployment of a new version, or maybe it's not the same if you are working for a big shop, right? A company that have a website for selling things. It's not the same the week before Christmas than, I don't know, one day in the middle of the summer. The peaks of traffic that you are gonna need to support during the week before Christmas are higher than in the middle of summer, right? Or for instance, a political decision, or if we remember the coronavirus, right? The traffic that companies like Netflix had to support, because everybody was on their homes, right? So watching a series was something that we wanted to do, right? So they have a lot of more traffic at that point, so that are events, right? But also can be things like a deployment or whatever. The metrics, we have been talking about them too, right? Profiles, we have been talking when I show you the metric, the traces, that actually this is somehow profiling, right? But it's a profiling of a pretty high level point of view, because what we have been seeing here are like the interaction between services, right? Things like that. It's not like when you are doing profiling, right? You can see exactly different functions on how much time you spend on CPU and memory in the different functions and parts of your code. So the idea is like with this profiling, you will be able to see profiles from your applications in real time in the production environment. So the things that with this, something that is pretty important with this thing related to observability is that since you are not working on the staging cluster in the staging environment, you are working on the production environment, you are seeing exactly how the system is actually behaving. It's not a guess of what do you think is going to happen, right? When you are doing profiling as part of your development, what you do is like profiling the functions that you think that are the most important. But now with this, it's like, no, you are profiling exactly what is used. Right now, for instance, for the OpenTelemetry thing, there is a proposal that, to be honest, I don't know how complete it is, right? But it's something that, well, you can go to the website, right, and take a look, because it's like pretty interesting to see how this kind of stuff is gonna work and make our lives easier, right? We have also logs. We were talking about them. Exceptions in the sense of what we know as an exception, right? When we are running Java and we have a crash and we can see all the stack trace and everything. If you have been working, for instance, with things like Sentry or with that tool from Google that I think is just for mobile phones, that is Google Crash Analytics, I think is integrated with Firebase. You can see that when the application is crashing, is breaking totally, right, you are receiving a report with the crash and some information that is gathered from the process. So this is another signal, right, for observability, because, well, if you start seeing that you are having a lot of exceptions and some of them are showing, so you are having those exceptions, right, maybe with the logging and the other things cannot be enough. You will probably need, right, to take a look into the stack trace and things like that. So maybe tools like Sentry and Crash Analytics will provide you a lot of help. And well, everything that we can have, right, to check when something is breaking is something that we have to take into account, right? So I always do this question for different talks that I do. Is it the technology for me, right? It's something that you have to take into, you have to think about, right? But in this case, right, it's not like, for instance, Kubernetes, right, where you maybe can use one of those managed services where you don't need a full Kubernetes instance, right? You don't need to create your on-premise thing, or you don't need to manage it even when it's hosted by Amazon or Google. In the case of observability, it provides you with some tools that are gonna help you to find what's happening, right, in your system. But well, this is not a pitch about observability or trying to sell a technology, right? You have also to take into account that this technology, well, you need to deploy things like, for instance, the OpenTelemetry collector, things like if you are using Prometheus, you have to deploy one Prometheus instance or Thanos if you want high availability, right? Or Jaeger or Grafana Tempo or whatever. So it's something that you have to take into account if you need it, because maybe your system is not having too many requests, maybe you don't need that, right? Maybe with logging and metrics is enough. Or maybe, yeah, right, because maybe you are gonna spend money there, but you are gonna be like able to sleep in the nights because you are gonna be able to find problems pretty easily, right, and fast. And also something that you have to take into account is that, well, gathering information is okay, it's nice, have that data, but you need tools to also convert that into information, right? Because otherwise it's gonna be just data that you can not do too much with that, right? So thank you for listening to me. I will be available in the chat, or even if you want to send me a tweet or whatever, or a LinkedIn or any other social media thing, just feel free to ping me and we can talk about observability and different things. Thank you. I hope you enjoyed it.